Okay, in the next couple of videos, we're going to be talking about how science and math deal with numbers. We're going to deal with mathematics and rounding and calculations in science. Now, this can be an area that really gets students and makes it really difficult for them because you've never seen this before. I'm going to tell you that a lot of people struggle when they don't take notes along the way and they don't listen for details. So I encourage you to really listen for details and do all of the calculations that I'm doing and all the things I'm doing. Take notes with me. Okay, you might need your calculator for what we're doing, so grab up your calculator. If you don't have it, pause the video, grab your calculator, be ready, because in the next couple of videos we're going to be doing calculations. Now, there's a big difference between how science and math deal with numbers. So let's talk about this real quick. Now, I apologize that my whiteboard has some scratches over here. We'll just sort of deal with that. Math and science are very different when we deal with numbers. Now, if you're dealing with numbers, plus, minus, multiplication, division, it's all the same. It's calculator work, or maybe you can do them in your head. But how we deal with numbers is very different. In math, you're just trying to get the answer. Okay, so the teacher makes up numbers. You're going to take 5 times 35.6 and you get your answer. In science, you're going to be using more of measurements, things that you actually measured, and you're going to do calculations with that. So you're going to be using data to do that. And it's very different on how we do it. Now, the functions are the same, addition, subtraction, multiplication, division, but how we're using it is very different. Now, chemistry is the first class that's going to deal with these things. Any math class, any science class that you have past this, you're going to have to know this skill. Whether you're going into physics, second year chemistry, you're going to go into AP biology, any other math-based science class is going to have this skill. So what we're going to deal with today is what we call significant figures. Okay? Now, it's how we deal with numbers. How we deal with numbers in a science class. Okay, so let's take an example. See if I can give you a couple of things that might work out for you. So I'm gonna turn that thing over for a minute. Okay, if you're working at home, there's all kinds of things that you can cook with. Okay, this is a 1/4 cup measuring cup. Okay, and this one is the smallest of the teaspoons that I have. This one actually says a pinch. Okay, so if you read a recipe, it says a pinch of something. You fill that up, and that's a pinch of it. Did you know that that was a measurement? It is in baking. But this is the smallest that I have. When we go to measure things, we want to be exact. Okay, for example, if I needed 1/8 of a cup, which is half of this, okay, when I look at the side of it, there is no measurements on the side. How do I know how to exactly get half of something? And if you've ever baked before, or if you've ever had to build something before, exactness, being accurate, exact, is super important. Now, it may not be tools like this. It may be something like this. This is a measuring cup, okay? And with the measuring cup on this one side, it may be hard to read, but it's going to say a 1/4 cup, 1/2 cup, 3/4 cup, and a full cup. Over here on the other side has the same measurements, okay? Or it says fluid ounces in the middle, okay? Now, on the other side, it would actually be in milliliters. Now, that's more scientific if you've done that in other science classes. 50 milliliters, 75, 100, 125, 150, but let's say that I needed not 100 or 125, I need 110 milliliters. Well, it's going to be really difficult to get 110 milliliters with this tool because it doesn't have a measurement for that. Okay? Or when I do measure, how do I make sure I'm accurate, I'm exact with what I'm doing? Now, if I had a bigger measuring cup, it's a really big one, this one goes 4 cups, 3 cups, 2.5, 2. Okay, on the other side, there's the fluid ounces in the middle. Quarts on this side, okay, 1 cup, 2 cups, 3 cups, a quart. Okay, on the other side, it's got other measurements. Okay, 200 milliliters, 300, 400. How do I get 100 milliliters in here? Okay, your tool is very important. So in science class, we're going to be using tools to get data, and we're going to use that data for measurements. Very different from a math class. In a math class, they tell you numbers, and you take those numbers and you raise your hand and say, where do you want me to round? Well, in science, it doesn't work that easy. Okay, this is a candy thermometer. Okay, and I'll turn it like this so you can see it. That candy thermometer. Okay, and you can measure the temperatures that you have candy. When you're heating it up, if you go over a certain temperature, you can actually burn the sugar so the candy's not even good anymore. And there's certain ranges of temperatures, so you need to have a thermometer. In this case, it goes very high. Okay, this one goes up to 400 degrees. Okay, but I have to keep it within a range. And if you've cooked before or barbecued or something like that, if you barbecued before, this is a meat thermometer. Okay, and you'll see that as I grab it up, you'll see the dial actually moves. Okay, my body temperature will actually make that move. If I'm cooking pork chops or something, pork has to have an internal temperature of a certain temperature. Okay, Google, what's the internal temperature of pork in order for it to be healthy?
145 degrees Fahrenheit.
145 degrees.
Business.com.
Exactly. 145.
Research from University of Illinois meat scientists. Pork enthusiasts can improve taste, juiciness, and tenderness by cooking.
Okay, Google, stop. Perfect. And so 145 degrees Fahrenheit, and there's a lot of details that Google was just telling us. Okay? But that internal temperature, so when I stick this in there, I have to have...
I don't understand.
Thank you, Google. All of the information that I need from this tool has to be accurate enough that I cook things so that I don't get sick. Okay? And so I have to have the right tool for the job. And so there's a big difference between when we deal with numbers in math and we deal in science. Okay? Rounding is very different in science. How we treat numbers is very different. So let's take an example here for a second. Let's say, and I'm just going to use a measurement that we all know. Sometimes I like to play golf with my friends. I'm not a very good golfer, but I want to play golf with my friends. I play too much baseball, so my swing's not very good. I hit it a long way, but it doesn't go straight. And so if I were sitting in the middle of the fairway and it's 50 yards to hit the ball into the hole, or 50.0 yards. There's a very big difference in science between these measurements. Now, in math class, it doesn't matter if you have 50 or 50.0. In a math class, they tell you it doesn't matter how many zeros you put on a number, it's still 50. Now, that's true. But these are measurements, and when we deal with measurements, there's a big difference between this number and this number. So let me ask you a question. If I'm correct, one of these two numbers, as you look at them, seems more accurate, and it's that one. Because the 0.0 seems like that one's probably measured. This one could be estimated, I'm not sure. Because see, if I'm golfing, if I just know it's about 50 yards, it's good enough. I'm going to try to hit it that far. But if I'm a professional, I want to know exactly how far it is because I know how to hit it that far. Okay? And so how we deal with numbers is very, very important. And so science finally had to stop and say, okay, everyone stop. We're all going to deal with numbers the same way. We're going to round the same way. We're going to measure the same way so that when you have numbers, they mean the same thing. Now, in today's world, have you figured out how people will use statistics and data to make it seem what they want it to be? You'll look at some data, and some people will take part of data and try to make it say what they want it to say. So science is really trying to fight against that. Okay, everybody does numbers the same way. Everybody rounds the same way. And so what we had to do is we had to come up with rules called significant figures. Significant means important, figures, numbers. So important numbers. Okay, and so you may say, well, all numbers are important. Well, that's correct, and I get that. What's going to give us problems are zeros. Zeros are going to give us a problem because we can't tell whether a zero has been measured exactly or not when it's written on paper. So we had to set some rules that said, here's how we're going to deal with numbers. So what we're going to do, and make sure you're taking notes with me here as we go, rules for Sig Figs. Now, this is an abbreviation. Significant figures, Sig Figs. Now, sometimes in some books, if you ever hear what are called Sig Digs, significant digits, like digits of a number, means the same thing. So I just want to make sure you've heard that before. Rules for significant figures, rules for important numbers in science. So we're all doing the same thing. Rule number one, okay? All non-zero numbers, and I'm going to abbreviate, are significant. All non-zero numbers are significant. Now, I've already told you zeros are going to give us a problem. So let me give you an example here. If I had 11 centimeters, and I'm just going to use centimeters for every one of these, just use that measurement. I'm not going to change it. Okay, 11 centimeters. Okay, rule one says anything that's not a zero is important. So that's an important number. That's an important number. There's two Sig Figs. Let's look at another one real quick. If I had 45.6 centimeters, following this rule, anything that's not a zero, that's important, that's important, that's important. So there are 3 sig figs in that number. Now, you're going to see that I'm putting lines on it. It's going to help me count, and you'll see as we go along to make it jump out where I visually see what's going on. There are 3 sig figs in this number. Why? There's no zeros. Okay? Anything that's not a zero is automatically important. Rule number 2. Zeros between non-zeros are significant. Zeros between non-zeros are significant. So let me take an example like this, see if this makes sense to you. 100 yards, 101 yards. If I were asking you which one of these is probably measured, about 95% of you would say this one. Here, that could be a guesstimate, just written there like that, I'm not sure, but this one really stands out. When I say it's 101 yards, they probably measured that. It just fits in our brain like that. That one lends itself to being, could it be rounded or is it exact? I'm not sure. Okay, so this zeros between non-zeros is what is called the sandwich rule. This is what I learned it forever ago, and I hear lots and lots of people call it this sandwich rule. And here's how it works. 101 centimeters. So here's our example. So you go back to rule 1. All non-zero numbers are significant. So that's important, that's important. Rule 2, zeros between non-zeros. See that zero? It's sandwiched in. You know what a sandwich is? It has bread on both ends. If it's got something on both sides, that's automatically important, zero. You may think, I don't understand why you're doing this. Follow the rules as we go along, it'll make a whole lot of sense. Now, what if the number's not like this? What if it's like this? 4,0,0,0,4 centimeters. Okay, rule number 1, anything that's not a zero is important. Okay, those are important. Number 2, zeros between non-zeros, the sandwich rule. Do you see things on both sides? Yeah. And so all 3 are important. Okay, so it'd be 1, 2, 3, 4, 5. So this has 5 important numbers in it when this one has 3 important numbers and that one has 2 important numbers. So what we're trying to figure out is the numbers you have, how many important numbers does that thing really have? Okay? Now, here's what's really interesting. Take that same number again and let's put a decimal right there. So that would be 40.004. How many sig figs in that? Okay, follow the rules. Rule number 1, it's not a zero. That's an easy one. Zeros between non-zeros. Sandwich rule. It can cross over a decimal. Doesn't matter. As long as you have something on both sides. 1, 2, 3, 4, 5. This has 5 sig figs in it. Okay? As long, it doesn't matter where that decimal is. Even if that decimal would have been there. If there's something on both sides, those are important zeros. Now I'm going to show you in a minute some zeros that aren't important. Okay? So the sandwich rule is pretty easy. Rule number 3, and this one's the hardest. Okay? Really catch how I'm going to say this. Okay? Zeros at the end of a number, it's supposed to be the at sign, let me do that a little better. At the end of a number and after decimal are significant. Now let me explain this real quick. You have to follow both these criteria. Number 1, it has to be at the end of the number, and number 2, it has to be after the decimal. Now that's going to be sort of confusing until I do an example. Okay? So here's an example. 45.0 centimeters. How many sig figs? Okay, rule number 1, anything that's not a zero. Got it. Number 2, do I have the sandwich rule? Well, I have something here. There's the zero. Is there something on the other side? No. So the sandwich rule doesn't count because there's not something on both sides of it. Rule number 3, zeros at the end of the number. Okay, that one's at the end of the number. That's the criteria. And is it after the decimal? Yes. So that's an important zero. Here's the logic. If I have 45 centimeters and 45.0 centimeters, if I put the 0.0, doesn't it look like that's probably been measured? So that's probably an important zero. That's where this rule comes from. In order for this rule to be true, you have to have both parts. It's at the end of the number, and it was, and it has to be after the decimal, and it was. Let's look at another one. 605.0 centimeters. Rule number 1, all non-zero numbers. Got it? Got it. Rule number 2, do I have the sandwich rule? Yes, right there, I see it. Is that the sandwich rule? No, it's not. Rule number 3, zeros at the end of the number. Got it. And it's after the decimal. Yes, it is. So this one has 4 significant figures. If this was not here, then it just would have been 3 using the sandwich rule. Okay, so you're trying to figure out how many important numbers are in there. Okay, so here's one, 400.0. Okay, so let's follow the rules. This one's a little tricky, so watch this one. Okay, rule number 1, all things not zero. Got it. Rule number 2, sandwich rule. Do I have the sandwich rule? Nope, there's nothing on this side. Rule number 3, zeros at the end of the number. I see a lot of zeros at the end of the number. Okay, lots of zeros at the end number and after the decimal. That would only be that one, wouldn't it? Okay, it's at the end of the number and it's after the that's only that one right there. But look what just happened. I now have rule 2, zeros between non-zeros. Now, but Mr. Kelly, that says, well, let me fix this rule. Zeros between non-zeros or zeros between significant. So fix that rule, are significant. So since this became an important zero, and that's an important zero, I now have something on both sides, so the sandwich rule catches them all. So all 4 numbers, 1, 2, 3, 4, must be significant. Now I know that's hard, so I'm going to do that again. Okay? So rule number 1, got it. Rule number 2, zeros between non-zeros, sandwich rule. I don't have the sandwich rule right now. Rule 3, a 0 at the end of the number, there's one at the end of the number, and after the decimal, that's important. All of a sudden, now I have the sandwich rule. See something on both sides? So that has 4. Sort of tricky. Got to be careful. Okay? So that second rule, zeros between non-zeros and zeros between significant. The reason I didn't put the word significant, are significant, wouldn't make sense until we got here and we saw it. Okay? Rule number 4. So how do you know if you have an important zero? How do you make something important? This one's going to help you. A bar over a 0 or a free decimal are significant. Okay? So let's take something like this, 40 centimeters. Rule number 1, all non-zero numbers, got it. Rule number 2, I don't have the sandwich rule. Rule number 3, 0 at the end of the number, yeah. But is it after the decimal? Well, I know the decimal's right there. It's not there right now, but I know from math class the decimal we know it to be there. Is it after the decimal? No, so that rule doesn't count. So right now, the way it is, this has one important number. What's really happening here is I'm saying I don't know. When you wrote it on paper, I don't know. So what if I really wanted to tell you that that is an important exact zero? You can do it one of these 2 ways. You can put a bar over the 0 saying, I'm telling you it's significant. That would automatically be 2. If you put a bar over 0, now be careful. You know, in math class, if you had 4 1/3, that's 0.3333 repeating. A number like that repeating is what that means. That's not the same as this. Okay, if I have a 0 with a line over it, I'm telling you, that's the way they do it in books. I'm telling you that it's exactly 40 centimeters. Or the other way they do it in other books is like this. They will give you a free decimal, meaning it's just sitting there with nothing after it. So there's a free decimal. 1, rule number 1, 0. Anything that's not a 0, got it. Sandwich rule, nope. 0 at the end of the number, after the decimal, nope, but I see the decimal now. A bar over the 0, nope. A free decimal. If they put the free decimal, they're telling you. So you can either, you don't do both, you can either have a free decimal or a bar. So you can have a bar or, and these mean the same thing, they would both have 2 sig figs. Okay? So that's how you make a 0 be important if you need it to be. Rule 5, all other zeros, they are placeholders, not significant. Now you may think, I don't know what a placeholder really is. Now that you're doing these rules, when I do it here in a second, you'll know exactly what I'm talking about. Okay? Here's one that works like this, 0.04 centimeters. So when you look at it, rule number 1, got it. Rule number 2, there's no sandwich rule because there's nothing on this side. 3, 0's at the end of the number. There's one after the decimal, but is it at the end of the number? No. Is there a bar over 0? No. Is there a free decimal with nothing left? No, the decimal's in the middle of the number. It says it's a placeholder. Why? That doesn't make sense. It will right now. about third, fourth, or fifth grade, you learned how to do fractions and decimals. If I'm correct, this is tenths, hundredths. This is 4/100ths. That's the fraction that is that decimal. And we don't do that hardly anymore, but you've seen that before. Tenths, hundredths, keep going, thousandths, 10,000ths, 100,000ths. Okay. So most of us know 400ths. Got it. Question, is it 0 400ths? No, that's silly. So is really the 0 part of the number? No, that's why it's a placeholder. It's not significant. So if you have a placeholder, is it 0.0400ths? No, that looks silly too. Okay? So anytime you have those zeros like that, they're just placeholders. So let me take another one. 400 centimeters. Rule number 1, got it. Rule number 2, sandwich rule. Nope. Rule number 3, zeros at the end of the number. Yeah, I got them, but are they after the decimal? No, the decimal's there. That doesn't work. Bar over 0, don't see one. Free decimals, not there. These are both placeholders. So there's only one important number there. Now, this one tricks people all the time, and let me show you one with money. This will make sense. If I had this and said, I have $50,000, but really I had $49,950. Okay, if this is how much I really had, I wish, but if I had this much money, I could tell people I have $50,000. I'm only $50 away. I've got so much anyway. I basically, see how it's rounded? Okay, people round things all the time wrong. Okay, real life, ready? Your grandma always rounds her age down. Boys always round their height up. Girls always round their weight down. It's just how life is, right? You might laugh, but it's true, right? Guys will tell you they're taller than they are. Girls will tell you their weight less. Grandmas tell you, I'm 21 again, and you're like, you can't be 21. The math doesn't work. Okay? So we round all the time. If you had 49,950, you'd say that's 50,000, but it's not. Okay, you rounded too much. So when you have a number like this, 50,000, what is really happening is the only number I'm really sure of is that. Are those rounded or not? I just can't tell. Okay, so if you want to tell me that they are exactly, you had exactly 50,000, that would be one way to do it without the decimal, or with the decimal, you would have that free decimal on there, and that would say, okay, significant, sandwich rule. Nope. Zeros at the end of the number after decimal. No, I have a free decimal. There's my free decimal, so that's automatically important, which means I now have the sandwich rule. All of them now occurred. Okay? But if they don't have any of that, they are placeholders. So what if you had something like this, 4.3 times 10 to the negative third centimeters? Now, it's been a while since you've probably seen numbers like that, but reminder, on a number line, times 10 to the negative third means move the decimal 3 places this way. So you go 1, 2, 3. So that's really 0.0043. So I'm going to put that back the way it was. Okay? Put it back the way it was. And so, question, if I look at this, Rule 1, got it. Rule 2, don't have it. Rule 3, end of the number, they're not the decimal. I don't have a bar or a free zero. These two are placeholders. So this has 2 sig figs. Now I'm going to show you the coolest shortcut ever. Okay, I got to show you one more, and then I'll show you the shortcut. I'll put not significant. I'll move those words for a minute. So what if I had something like 6.7 times 10 to the negative 13th? Woo! I shouldn't have picked that. I'm going to go 13 places back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6, 7. There's that number. Wow, 13 places back. Rule 1, got it. No sandwich rule, zeros at the end of the number. That doesn't work. I don't have a bar over 0 or free 0. Those are all placeholders. So how many sig figs did I have? 2. Ready for the shortcut? Here it is. Whenever you have times 10 to a power, you make placeholders. So all you have to do is look right here. How many numbers are right there? 1, 2, that's the answer. How many numbers are right there? 1, 2, that's the answer. It's really that simple. Let me show you 2 more real quick. Okay, this is the easiest question to ever answer. So if I have 5.67 times 10 to the 12th power, means I'm going to go 12 places that way. 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Got it. Decimal's there, but it's way out there. So here's question. 1, 2, 3, that's rule 1. Zeros, no sandwich rule. Zeros at the end of the number, yep, but they're not after the decimal. No bar, no free decimal. Look right there. Answers that. But what if it was 5.67 times 10 to the 42nd? Well, I'd have a whole lot more zeros, but they all have what job? They're placeholders. So all you have to do is count right here in the front of the number, 1, 2, 3. That's automatically your answer. Always. Never breaks that rule. Never, ever, ever breaks that rule. So what if I had 1.01 times 10 to the 4th? 1, 2, then 2 more places. 10100. Rule 1. Got it, got it. Rule 2. I see the sandwich rule. Rule 3. Zeros at the end of the number, but they're not after the decimal. No bar, no free decimal. How many numbers are written there? 1, 2, 3. The answer is 3. Okay, so what you're going to do in the next video, you're going to do a section called NYT, which stands for Now You Try. And so what you're going to do is you're going to try a few, and then I'm going to give you the answers just to see if you're doing it right. So check it out in the next video. Good luck. I bet you can do this. Use your notes to help you.